Picture a powerful pump in a factory, moving thousands of liters of fluid every minute. The spinning shaft must exit the pump casing, creating a major leak risk. Enter the mechanical seal, a precision device that prevents leaks where a rotating shaft passes through a stationary housing. It's not just about avoiding puddles, it's about safety, efficiency, and protecting the environment. The seal works by pressing two ultra-flat faces, one stationary, one rotating, together with a spring. This tiny component keeps entire industries running safely and efficiently. It's a small part with a massive impact. Let's dive into the single mechanical seal, the most common type. It features two faces. One rotates with the shaft, the other stays fixed in the pump housing. A spring pushes these faces together, with the process fluid on one side and the atmosphere on the other. The process fluid forms a thin film between the faces, lubricating and cooling them. This design is simple, reliable, and cost-effective for non-hazardous fluids. You'll find single seals in water pumps, food processing, and general industrial applications. They're easy to install and maintain, making them the workhorses of the pump world. However, a single seal always allows a tiny, often invisible, amount of leakage. That's fine for water or mild oils, but not for hazardous or volatile substances. If the seal faces fail, the process fluid leaks directly out, making single seals unsuitable for dangerous or abrasive fluids. They also struggle with very hot or poorly lubricating liquids. When safety or zero leakage is critical, single seals reach their limit. That's when we need something more robust. When a single seal isn't enough, engineers use the double mechanical seal. This setup features two seals in series, creating a chamber between them. The inner seal faces the process fluid. The outer seal faces the atmosphere. The chamber is filled with a special barrier or buffer fluid managed by an external system. This design isolates the process fluid, offering superior safety and reliability. Both seals are lubricated and cooled by the clean fluid in the chamber, not the process fluid. This extends seal life, especially in harsh or hazardous services. Double seals are standard in chemical plants, refineries, and anywhere leaks are unacceptable. If the inner seal fails, the barrier fluid contains the leak, preventing disaster. The double seal's controlled environment protects against toxic, flammable, or abrasive fluids. It's a system built for the toughest jobs, where failure isn't an option. The extra complexity is justified by the safety and reliability it provides. Double seals are the ultimate defense in critical applications. The fluid between double seals is crucial. It can be a barrier fluid or a buffer fluid, depending on pressure. A barrier fluid is kept at higher pressure than the process fluid, so it leaks into the pump if the inner seal fails, never the other way around. This ensures total containment for hazardous or toxic substances. A buffer fluid, on the other hand, is at lower pressure than the process fluid. Here, the process fluid leaks into the buffer if the inner seal fails, and the buffer fluid collects any leakage before it reaches the atmosphere. Barrier fluid systems are used when zero leakage is essential. Think toxic or volatile chemicals. Buffer fluid systems are for less hazardous duties, improving seal life and containing minor leaks. The choice depends on the fluid's danger and the level of containment required. Get this right, and you protect both people and the environment. The right fluid system is as important as the seal itself. It's a critical decision in pump safety. Let's compare single and double mechanical seals side by side. Single seals have one pair of faces, simple, affordable, and easy to maintain. They're perfect for non-hazardous fluids where a minor leak isn't a big deal. Double seals use two pairs of faces and a barrier or buffer fluid, adding complexity but vastly improving safety. If a single seal fails, the process fluid leaks out immediately. If a double seal's inner face fails, the barrier fluid contains the leak, preventing exposure. Single seals are cheaper and simpler, with lower installation and maintenance costs. Double seals require more investment, extra hardware, fluid reservoirs, and monitoring systems. But double seals excel with abrasive, hot, or hazardous fluids, thanks to their controlled environment. They're the go-to for critical applications where leaks are unacceptable. The trade-off is clear simplicity and cost versus safety and reliability. Choose based on the fluid, risk, and regulations. Both have their place. Pick the right tool for the job. That's the engineer's challenge. So, which seal should you use? It depends on your application. Choose a single seal for standard duties: non-hazardous, non-toxic, and non-flammable fluids. Water pumps in buildings, food processing, and mild chemicals are perfect examples. Single seals are cost-effective and easy to maintain when a small leak is no big deal. But when safety is paramount, handling toxic, flammable, or corrosive fluids, a double seal is essential. Regulations often require double seals for hazardous substances. Double seals are also best for abrasive slurries, poorly lubricating fluids, or those that solidify on contact with air. The decision is a risk assessment. What's the consequence of a leak? If it's just a puddle, go single. If it's a fire, toxic release, or environmental hazard, go double. The right choice protects people, the environment, and your bottom line. Don't cut corners on safety-critical applications. Invest in the right seal for the job. It's peace of mind, engineered. Mechanical seals aren't fit and forget. Maintenance is key to long life and reliability. Single seals are straightforward. Keep the pump running smoothly, avoid running dry, and watch for leaks. Most failures come from dry running, vibration, or pressure spikes. Regular checks and prompt replacement keep single seals working for years in clean service. In tough conditions, expect shorter life, maybe a year or less. Double seals need more attention. Monitor the barrier or buffer fluids level, pressure, and cleanliness. External systems may have alarms for low pressure or fluid loss. With proper care, double seals can last 5 to 10 years, even in harsh chemical service. The clean barrier fluid protects the faces, reducing wear. Maintenance is more complex, but the payoff is longer life and fewer failures. Invest in regular checks and you'll avoid costly downtime. The right maintenance strategy maximizes seal performance. Reliability starts with good habits. In the end, choosing between single and double mechanical seals is about balancing simplicity and cost against safety and reliability. Single seals are champions of economy and ease, perfect for low-risk fluids. They're the backbone of industry where leaks are minor inconveniences. Double seals are the guardians of safety, built for hazardous, abrasive, or extreme conditions. They provide robust, redundant protection where failure isn't an option. Ask yourself, what's the real cost of a leak? If it's just a cleanup, single seals are your answer. If it's harm to people, the environment, or your business, double seals are essential. Make the right choice for your process and your peace of mind. That's the power of understanding mechanical seals.